Welcome to part 2 of this most important master question for moment of inertia. Remember, very important, in the most important part, very important, that is I about xx and yy, that is centroidal axis, one of them is horizontal, xx, other vertical, already over in part 1. That is the real master part. This already over last time. So, when you come to part 2, it is understood that you already thoroughly studied part 1. Okay, now, part 1 over, see, ixx, iyy over. In part 2, what we will do? We will find moment of inertia about this one. BC, AB, sketch is still there. See, they can ask anywhere. See, in a question, moment of inertia can be asked either about centroidal axis or any random axis. So, today's part is random axis. More important academic purpose or a competitive examination. Structural engineering point of view, not that much important. But remember, most important concept for steel structures is at the end of part 2. So, end of part 2, what I am covering is very important for steel structures. I will tell why. That will come at the end of the part 2. Okay, now I will make ready now. See, I will tell one by one. See, they want I about BC, AB, then AF. See, AF means this line, AF, this axis, AF, then DC, CD or DC, ED, this way, and FE, FE, and also 4 axes outside, 1, 1, 2, 2, 3, 3, 4, 4, one at a time. For all of them, remember, this is our division. Okay, now we will start one by one. First, you have to make a note. Before I start calculating, first one note required. Okay, this I will remove now. So I will do one thing now. See, this is already over. Now, this note I will not tell every class. Now means now, that is in this part 2. In this part 2, we will find I about, see, BC, comma, see, BC, comma, I about AB, etc. Lastly, up to I44. See, all these we will find. Here, these right here. See, last time, you make one more note. Last class, part 1, we found about xx and yy. That is centroidal axis. Therefore, first we have to locate centroid. Locate centroid G for the whole cross section, which we have done last time. We got x bar, y bar. Then we found ixx, iyy. But for all above, but remember, one at a time. Because nowhere in exam, actually they will ask you one question. This way, so total how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This 10 will not be asked. 1 only will be asked. So, at a time 1. But for all the above, there is no need of, there is no need of locating centroid. Centroid G for the whole section. Why? Because they don't want moment of inertia about centroidal axis. Therefore, directly start as soon as question given. Or you can make a small note here. Suppose question is There is no question regarding ixx, iyy. Question is only I about the required axis. Therefore, don't waste time on finding centroidal axis, locating centroidal axis. Even if you locate, waste of time. So, one at a time, we will calculate. Okay, now, I will do one thing now. See, all about all those 10 moment axes, moment of inertia, I will calculate myself first so that no calculation mistake. Actually, it won't take much time for me. Maybe another 5 minutes it will take for me to find all. I will somewhere here, I will write all the answer so that as you calculate, we check the answer. There's a reason for it. I will tell you at the end of the class. Okay, I will make ready for one by one. Okay, I will start now. You can see, I noted all the answer. You can see this yesterday's x bar, y bar. Some people will tell, sir, you just now told for finding all about this one, you need not locate centroid. Yes, I told. But you used that answer. That I will tell you afterwards. Why, how I use this value, that is my trick, not trick actually. It comes the end of the class. So right now, I have not used it. You imagine, you calculate it. See. Now, start one by one. See. All dimensions in millimeter, all I told last time. Division is like this. Like this, here, see. Next. First one by one now. I will use a black color because this is second, not that much important as earlier. So, but still you understand. See, calculation of I don't want to waste time. Moment of inertia, I about one by one, BC first, IBC. But before that, do one thing. Before that, make a note here. Note. For all calculations, use parallel axis theorem. You write. That is, once again I will write here, I about red color. This is not centroidal, about any axis equal to green color. This thoroughly explained. I won't waste time now. Ig plus area into h square. This explained very, very thoroughly. I won't waste time now. Okay, start. Now, first, I'll put the sketch here. See, first, calculation of one by one now. I can save some time today, 1 minute. Calculation of I about BC. First, I'll do BC. What you do is put the cross section here. See. Somewhat to scale, 16, and this is exact scale not required. Okay, little bigger, out of scale. Sufficient. Okay, IBC. But I will do one thing now. I will change the order first of all. See, this is little lesser. Okay, 16 here. This is little lesser. Okay, now it's reasonable. See, 16. This is 150. This is 20. This is 130. The overall, if you want by chance, the overall dimension, full depth is 170. Okay, now, this is your part 1. Dividing into part C, this is your part 1. This is your part 2. Part 2. It may disturb later. Okay, no problem. Part 2. Okay, now mark that axis. Red color not required, but okay. I will mark red color because it is a required axis. I will use red color. Mark that BC. Where is BC? See, BC is here. BC. This is the axis. I about this axis required. So IBC, right here. You put the sketch and write IBC equal to, by parallax theorem, no time waste, I'll write where some space here. I about BC equal to, first see, as usual, centroid G1, centroid G2, these all explained for you. If you want I about BC, first write I about its own centroidal axis, 16 into 150 cube by 12. I use black color because black looks neat, but it is IG, remember. 16 into 150 cube divided by 12 IG plus area 16 into 150 is the area into from centroid of the component to the required axis. See, this perpendicular square is 20 plus 150 by 2. Red color. Okay. H square. 20 plus 150 by 2 close square. You get IBC. See, this is your IG to understand. This is your IG, this is area, and this is H. Answer will come in 10 to the power 6 millimeter power 4. We'll calculate. See, I about BC equal to IG parallel axis IG plus AH square. Now I want to waste time explaining too much. These all told so many times earlier. People who cannot follow means no problem. Let them not follow. 16 into 150 cube divided by 12 plus 16 into 150 into 75, 95 square. 26.5 is 50 now. But some other number is there. 1 nimisha. 16 into 150 cube divided by 12 plus 16 into 150 into 20 plus 150. Oh, one more term. I am wondering what is happening. That is for part 1. One more term is there. Oh, now space problem. Okay. Now there is space problem. I don't know how to adjust the space. It's correct, plus one more. I have checked whether space is there or not there. Below, can I write one more line? One more line, doubt. Okay, I will manage. Don't worry. This all I will manage. 130. Okay. I write once again, no problem, don't worry. Okay. I BC equal to start 16 into already explained for you 150 cube divided by 12 plus 16 into 150 is the area into from centroid to BC 150 by 2 plus another 20 whole square. So this is your, just to understand, see, this is your IG, this is area, this is H, this is H. Oh, this is for part 1, see, plus one more is there, plus for this one. This is for part 1, see, this is for part 1. Here, first I about its own axis, see, its own centroidal axis, it is here. How much? 130 into 20 cube by 12. 130 into 20 cube divided by 12 is IG plus area. Same, this is IG, this area. So you can see there. Once again, I won't write, space is not there. 130 into 20 is the area. It will neatly required because this is repeatedly coming now. Plus 130 into 20 is the area into, see, from centroid of the component to BC, perpendicular square is 20 by 2 square, that's all. 20 by 2 whole square. Calculate these two, it will come. Now we'll calculate, because I already got the answer there. How it is possible? The answer has to come same. Okay, now last answer was 16 into 150. 16 into 150 cube divided by 12 plus 16 into 150 into, that is 95 square. Okay, 95 square equal to, plus second one, 130 into 20 cube divided by 12. 12 plus 130 into 20 into 10 square. 26.50. Yes, answer is, I will put a black color only. 26.50. 26 divided by 10. Divided by 10 to the power 6. 26.50. 66666. Same answer. 66667. 10 to the power 6 millimeter power 4 is the answer. Yes. So IBC perfectly tally. Over. Now I will do one thing. To save the time, I will do one thing. See, I about BC over. That is this axis. Next they want IAB. No. First I will finish for all the horizontal axis. So therefore after IBC, see, IAB here afterwards. Next I will go for IAF. IAF, because to save the time, IAF. Calculation, okay. IAF, okay, red color I will use. Last time do one thing, you write I, last time you write IBC red color. Okay, now write IAF. AF. Start. See, I will tell you what will happen now. Mark, see, don't write BC now. Write one more sketch. If you want to learn everything, you write one more sketch. See, that's what you should seriously work out. This is your AF, see. A here, F here, A here, F here. So, this is your AF. If you want, you can extend the line. See, this is your AF. Now, start. First, I about its own center on the axis. 16 into 150 cube by 12, same as last time. Area same as last time, into, from centroid here to this distance square, this perpendicular square is 150 by 2 whole square. That's all. Plus, for this one, first you should write once again. This is H actually, forgotten. This is your H. Okay. Next, I about its own axis. 130 into 20 cube by 12, same as last time. Don't write same as last time, write once again. Plus area into, from centroid to AF, see, this distance square. See, this distance square is 20 by 2. 20 by 2, see, 20 by 2 plus 150. 150 whole square. Calculate the answer. It is 16 into 150 cube divided by 12 plus 16 into 150 into 75 square plus 130 into 20 cube divided by 12 plus 130 into 20 into bracket 10 plus another 150 close square divided by 10 to the power 6. 84.64. I am not seeing there. 64. Honestly, 64. 666666667. 10 to the power 6. Yes, see. This also tallied. IAF. Okay. Then, next. See. BC over. AF over. Then I do for ED next. Horizontal. One more horizontal. ED. ED. You write there. He is doing, instead of wasting one, if I write once for horizontal vertical, this will keep on changing. To save the time, he is finding for all the axes which are horizontal. Okay. Which one? ED. IED. Remove this one. Write one more sketch. Those who are serious do one thing, should draw one more diagram. You should not use the same sketch. See, this is your E, this is your F. You want I about this axis. See, extend further. Okay. Start once again. I about its own axis. 16 into 150 cube by 12 plus area into, now it is from here to ED. See, this distance square is 150 by 2 whole square, same as last time, plus I about its own axis, 130 into 20 cube by 12 plus area into only this distance square is 20 by 2 square. 20 by 2 square. Calculate. I think I am doing little fast. I need not explain. After reaching this level, 16 into 150 cube, next time I will do one thing. I will store in memory that one. Cube divided by 12 plus 16 into 150 into 75 square plus 130 into 20 cube divided by 12 plus 130 into 20 into 10 square divided by 10 to the power 6. 18.34 answer. I am not looking there. 18.34 66667 10 to the power 6 millimeter power 4. Which one? EF. Yes, see, EF. Why I put ED first there? ED, okay. CD, ED. Oh, no, ED here. ED. Okay. Correct. Tallied answer. Now, I will do one thing now. Now I will go for I for other axis. Other axis. Oh, there is some problem here about the distances here. Okay, I will manage. This 130 is troubling me. Next I do one thing. The space problem. I could have removed this one. Okay, leave it. Calculation of I about which one now? 1 1. I about 1 1. Okay. See, you should write once again. You should not be lazy and use the same diagram. If you want a complete grip, you should follow what all I tell. Otherwise, you are losing. See. Okay. Now, 1 1. Where is 1 1? 1 1 is 90 below. I will do one thing now. I will write 90 below here. See. Your 1 1 is here. 1 1 is here. From here, it is below by 90, given in the question. See. In the question given, below by 90. Now, this length required, I will put 130 here. Okay. I won't mark it. Okay, start. I about BC. Oh, last time, see, when I did I for ED, I forgot to change here. I first write I for BC, then, see, by mistake, I forgot to change here. Use that, you should know it. Second time, see, now, sometime it happens. See, after BC, next I did for which one? After BC, I did for AF. See, you should have written earlier AF here. Okay. Some will find mistake. He wrote still BC. No. I forgot. Then, just now, I did for which one? ED. At that time, you write ED. Because I'm explaining ED. You write that way. I forgot it. If you cannot do that much, what I can do? Then, now do one thing. Write I for 1 1. I about 1 1. Okay, start. See, first, I about its own axis. Same. 16 into 150 cube by 12 plus area into, see, from centroid here to 1 1. This perpendicular square is 150 by 2. It is 150 by 2. If somebody will find a mistake, he is doing I for EAF, still he wrote I for BC, he has not removed it. Such people, we can't do anything. 150 by 2 plus 20, see, from here to here. 150 by 2 plus 20 plus another 90 whole square. For second one, I about its own axis here plus area into this distance square, 20 by 2, see, from centroid here to here, 20 by 2 plus another 90 plus 90 whole square. Calculate. into 150 cube divided by 12 plus 16 into 150 into 75 plus 20 plus 90 close square plus 130 into 20 cube divided by 12 plus 130 into 20 into 10 plus 90 close square divided by 10 to the power 6. 112 point 112.72 to 66667 10 to the power 6. See here. Yes, this also tallied. Now, lastly, I of about 1 over next 3. I about 3. I write here. Calculation of I about 3. Okay, start. Where is 3? 3 is here. See, this is 3. 3. Okay. For that one, see, this 1 should not be there now. This 90 is not there. I should this I forgot earlier. You should make it I about 3. I told first two after first finding IBC, when I did IAF, I forgot to change it. But the calculation I told correctly. Okay, now this one. Start. First, distance from here to here, distance is, how much is? 80. Given in the question. So, okay, start. I about its own axis, it's here. Plus area into, now see, from centroid to 3, see, from centroid to 3, this distance square is 150 by 2 plus another 80 whole square plus second one, I about its own axis, already over, area 130 into 20 into from centroid to this axis, this distance square is 20 by 2 plus full 150 plus 150 plus 80 whole square. Calculate. Over. All horizontal axis over. Next round I will put one more sketch because become too dirty now. 16 into 150 cube divided by 16 into 150 cube divided by 12 plus 16 into 150 into bracket 75 plus 80 close square plus 130 into 20 cube divided by 12 plus 130 into 20 into 10 plus 150 plus 80 close square. I am getting how much? Divided by 110 to the power 6. 159. I 3, but it is 212 there. I'll check once again. 16 into 150 cube divided by 12 plus 16 into 150 into bracket 75 plus 80 close square plus 130 into 20 cube divided by 12 plus 130 into 20 into 10 plus 150 plus 80 close square. 21 point, yes, divided by 10 to the power 6. 212, because some calculation mistake, because that is correct. That I already verified it. It is using a trick actually. Since it is using a trick, that cannot be wrong. Trick I will tell you in the end of the class. End of the class I will tell you. That is required for steel structures. 212.00006667 10 to the power 6. See, this is also tallying. Okay. Now, I about all the required horizontal axis over. Now, see, now over now. 1 over and also 3 over. Now I will do for which one? AB, then CD, EF, 2 and 4. I will rub the board and prepare for it. Start. Now all remaining. I about AB. AB here. First, I about, see, axis passing to centroid, parallel to AB is here. Now, 150 into 16 cube by 12 plus area into, see, this distance square is 16 by 2 square. Here, I about its own axis, 20 into 130 cube by 12 plus area into this distance square, 130 by 2 square. I already calculated. Okay, tallied. Not calculating, it will come, my guarantee. Then I about AB over, next after AB, next CD. Where is CD? CD is here. Okay, remove AB. Remove that AB. That line is there, AB is removed. Red color is removed now, but black color is still there. Don't do like this, right? Once again. CD, where is C? Here, C. This is C, this is D, about this axis. So extend further. This is your CD. CD means extend further. Okay. This axis. Start. IG, same as last time, parallel to this axis. I forgot right here. See. Sometimes it happens. I forget it. CD. First, through centroid, parallel axis over. Area into this distance square is, see, this is 130. See, from here to here. This distance square is 130 minus 16 by 2. It is 130 minus 16 by 2 whole square. For this one, I about its own axis plus area into this distance square is 130 by 2 square. 50.419946667 10 to the power 6 millimeter power 4 tallied. Okay, so it will tally, I guarantee. Okay, now sometimes see, I change everything but forget to change here. People are there. Next, I about CD over EF. Where is EF? EF is here. See, this is your E, this is your F. I about this axis. This axis. Okay, start. IG, same as last time. 150 into 16 cube by 12 plus area into this distance square is 16 by 2 square. 16 by 2 whole square. And for this one, I about its own axis, same here. Area into this distance square. That distance square is here. This is 130. Be careful. This is 130. We want, see, from here to here. What to do? This is 130 means this is 130 by 2. See, it is 130 by 2 is from here up to here minus 16. That much you can make out. See, this is 130 by 2. This is 16. So this distance is 130 by 2 minus 16 whole square. Answer. Which one it is? EF. Okay, right. You write the answer. 10 point. Why should I waste ink? 10 point. 10.1090666667 10 to the power 6. Okay, now EF also over. I forgot write every time. Okay, write calculation of, I forgot write, you write here. Next, first write calculation of AB. Once you finish, you write calculation of ICD. Once I finish, you write just now calculation of IEF. Now write calculation of I about 2, 2. 2. Okay, mark 2. EF should be removed now. Now EF is not there. Okay, 2, 2. Where is 2, 2? See, 2, 2 is here. 2, 2. Where it is? It is 70 mm to left side, out of scale. This is given in the question as 70. See, this is 70 given in the question. Okay, start. I CD over, see, CD over. Just now, I forgot to change it to EF. You should not bother about those things. See, just now, finished last part, I forgot to change it to EF. You change it. I was explaining for that one. Forgot to change it here. You change it. It will work for you. Then I about 2, 2. So rounding is not required. 2, 2. I about its own axis here plus area into this distance square is 16 by 2 plus 70. So easy. See, 16 by 2 plus 70 whole square. I about its own axis here plus area into, see, this distance square is 130 by 2 plus another 70. 130 by 2 plus 70 whole square. Answer will come. Which one? I for 2, 2. 65.69946667 10 to the power 6. See, this also tallied. This also tallied. Okay, now, lastly, calculation of I 4, 4. This is not there. This is not there. 70 also is not there. 4, 4. Where is it? 4, 4? Somewhere here. See, 4, 4 is here. Out of scale. Okay, 4, 4. Where is it? From here, it is how much distance? 50 mm from here. Okay, start. I 4, 4. Closing part. I about its own axis here, area into, from centroid to 4, 4, this distance square is 50 plus another 50 plus full 130, 50 plus 130 will give you from here up to here. See, 50 plus 130 minus 16 by 2. Minus 16 by 2 whole square. Plus here, I about its own axis, already over. Area into, see, this distance square is 130 by 2 plus 50 plus 50 square. It will come. Its answer is here. This only will come right here. 109.09946667 10 to the power 6. Millimeter power 4. So this is over. Now I first thought of the last part, uploading separately as a critical example for steel. No, I decided to upload now only because those people who are lazy and not going to full part here, they should pay penalty. They should later when they go to steel structures, they should regret at that time. So I told everybody should go through everything uploaded by me. Okay, now lastly, see, everything over. You write here. Question. Our question is complete. Right here. Our question is completely solved. But still, a special information, which is required for steel structures. I will write first and then prepare it, then explain it. Now, the last part, make a note. I will dictate something. What I am covering now is very important for steel structures. Because see, you write here, given section is an angle section. Of course, one side is 170, one is 130. That you will not get in steel structures. Steel structures, you will have unequal angle and equal angle. Like 200 by 150 by 15. One leg 200, one leg 150. Thickness, both are equal. Or equal angle. 100 by 100 by 8. 100, 100 and 8. But this is class question now. What happens is, in steel tables, see, there's a term, actually it's not steel table, it is IS handbook for steel rolled steel sections, properties. But people usually tell steel tables because it is edited and printed. There, for angles, see, they will give angles here, equal or unequal, anything, see. They will give this way. Some curvature will be there. Actually, the edges are not straight actually. There is some curvature. For the complete angle, they will tell there where is centroid, what is this distance, what is this distance, they will tell. Then they will tell, this is, they will call XX axis. This they will call YY axis. Then they will tell you what is the area for the entire angle, what is these distances. This is called CXX there, CYY there. That you refer in steel tables. And what is I about XX and I about YY for the entire angle they will give. So there you are not going to break the angle and use that property and then get required moment of inertia. Okay, that's all sufficient. In steel structures, I will explain very thoroughly. Okay, now make a note. For our question, we finished everything, but still, one note you are right. See, what all I dictate you are right now. In the beginning, see, in the beginning of our question, we are asked to find, see, if you don't write, it won't be clear. We are asked to find moment of inertia about centroidal axis, IXX, IYY. For that, we have to locate centroid for the entire angle section. We divided into parts, 2 parts, and we located centroid, marked XX, marked YY, and found IXX, IYY. Remember, over. Now, then see, then they want I about so many axes. But remember, once you know I about the centroidal axis for the entire cross section, no dividing, then using that result, you can find I about any other axis very easily. How? I will explain now. See. Now what you do is class. Consider the entire angle. See, single hatching, no dividing into 2 parts. Full one angle. Centroid is here. We got this X bar. See, I am using green color. It is a property. These are properties of the given angle section. X bar we got 37.64 from here. This is 50.8, 130 by 170, 16, 10, 20. Complete compact one angle. Now do one thing. Start. Calculation of I about, see, once again, BC. I about BC. See what you can do. Full angle you write here. See, no dividing. BC is here. See what to do. I about BC equal to, first come to centroid of the angle. See, this is centroid for entire angle, not for cut. See, if you take only this, if you divide into parts, one centroid here, one centroid here. But for the entire angle, centroid here. If you want I about BC, first I about its own centroidal axis. See, IG plus AH square. Here, we already see this is already calculated. Otherwise, you can't do it. So, what I am telling now, you can use it only after finding I about centroidal axis. So, once you find I about centroidal axis, in the same question, see, suppose there is an independent question, find I about BC. Don't do all these things. Do what I have done earlier. But in a question, if you are asked to find I about centroidal axis and also some other axis, then you can do very easily using already calculated values of properties of centroidal axis. See now, I about, see first if you want I about BC, first I about its own centroidal axis, that is, see, this axis. For that axis, I is how much? 13.603466667 10 to the power 6. This is your IG plus complete area 5000. 5000 is complete area into perpendicular distance from centroid to required axis, this distance square, 50.8, already there, see, into 50.8 whole square. Calculate, you calculate, my guarantee, this is the answer. Write it there. I won't write. I have got 100% confidence. All answer is into 10 to the power 6 is there. Over. Now, I about BC over. Now, after BC, I'll go for which one? AF. Okay. See. AF. AF is here. See. This axis. Start. I about AF. I'll finish fast now. This actually requires for steel structure. First, I about its own centroidal axis. This distance. That is same here. Already there. Plus area into now, see, this distance square. That distance, from here to here, this distance square, that is total 170. See, total 170. From 170, subtract 50.8. See, this is whole square. Calculate, guaranteed, this answer will come. My guarantee. Okay. After AF, sorry, I forgot here, calculation of IAF. See, okay, over. Then find I about ED. ED. Mark ED here. See, E here, D here, about this axis. Okay, start. First, I about its own axis. This one. I am doing first for all horizontal axis. Over this axis plus area into, see, this distance square. This distance square is 50. I should change it. See, this I forget sometimes. I about ED. Okay, understood. If I don't change also, you change it. This distance is 50.8 minus this thickness is 20. It is 50.8 minus 20 whole square. Calculate, my guarantee, this answer. Okay, then red I will remove now. Only black color. Okay, this angle. Lastly, I about 1,1. I11. Your 1,1 is, where is 1,1? See, 1,1 is somewhere here. 1,1. It is given in the question, this distance is how much? 90. Calculate. I about 1,1 equal to, one more sketch you are right, equal to first I about its own centroidal axis here plus area of the entire angle into this distance square is 50.8 plus 90 whole square. Plus 90 whole square. This answer will come. Next, 1,1 over 3,3. Calculation of I about 3,3. 3,3 is here. See, 3,3 is here. Now this should be removed. This is not there. You should not write this one. 3,3. Okay. They told in the question that is at 80 from here. See, in the question given, this is 80. Okay, start. First, I33. Oh, 3,3. I should change here. 3,3. First, about I about its own axis, parallel to 3,3. This answer. Property. Area into from centroid to this distance square is 80 plus full 170. See, 80 plus 170 will give you from here up to here. We want this distance square is 80 plus 170 minus 50.8 minus 50.8 whole square. You will get I33 answer also over. Okay, now all horizontal axis over. Now I will go for vertical axis. Calculation of, you should write each and every one separately. Calculation of I about AB. I about AB. Your AB is here, see. This is your AB. AB. Okay, start. IAB. If you want I about AB, first I about an axis pass into centroid and parallel to AB is I about this axis. I about that axis, IG, is 7 point, see, already calculated. So you can do this one only after finding I about centroidal axis. 7.76, but important is in steel structures. 7.767, 7.7676, 18667, 10 to the power 6, plus area 5000 into, see, from centroid here to AB, this distance square, that is 37.64 square. 64 square. Calculate. This answer will come. After AB, next CD. I about CD. Everyone do independently. Don't write one sketch and do it. I'll get back original sketch. Okay, CD. CD is here. See. This is CD. I am putting red color. CD. I about this axis. First CD. Okay. CD. First I about its own axis, centroidal axis, parallel to CD. To parallel to CD, this moment of inertia is I about this axis is this one, plus area into, see, from centroid to CD, this distance square, that is 130 minus 37.64 square. This value will come. Okay, then after CD, see, I forgot change here, CD, okay. This you should not bother, CD, already over, okay. Now, I about, then they want EF, okay, I about EF. This is your EF, see, EF, E is here, F is here. Okay. First, I about its own centroidal axis, EF, same, this answer, plus area into, from centroid to EF, this distance square is 37.64, red color, 37.64 minus this thickness, you can see there, 16 whole square. That answer will come. Okay, then I about EF over I about 2, or closing part now, 2, remove EF, draw one more sketch. Okay, 2. Where is 2? 2 is somewhere here, okay, out of scale. 2 is here. In the question they told, this is 70 millimeter. Okay, first, if you want I about 2, first I about centroidal axis, this answer, plus area into, from centroid to this distance square, that is 70 plus 37.64, 70 plus 37.64 square, this answer will come. Okay. Lastly, I about 4, over, cross over. Where is 4? 4 is here. Write that, 4. In the question they told, it is at 50 mm from here. See, 50. Start. If you want I about 4, 4, first I about for the entire angle, see, centroidal axis for the angle, this one. This IG plus area into from centroid to this one, this distance square. That is, see, 50 plus, see, first from here to here is how much? 50 plus 130, 50 outside plus 130 will give you from here to here. From the, we want this distance square. So this distance minus 37.64 square 22. Calculate. Okay, last one I'll calculate. 109.09944467 not calculated. You will get this answer. So make a note. If they ask lastly, closing note by me, go through again and again what I told. Go through again and again what I told, what I am telling now. If they want moment of inertia about centroidal axis, locate centroid and find I about x, x, y, y, we will call it. If they want I about any other random axis, do not waste time finding centroid, locating of centroid and finding I about centroidal axis. Directly mark that axis and then find moment of inertia about that axis. Divide the given lamina into different parts. But if they ask I about centroidal axis and also about some other axis, if some other axis given, separately you can do like earlier. You can save the time. Once you know I about centroidal axis, using that you can find I about other axis. IG plus A square. Now IG means I about centroid of the entire lamina, what I told. And furthermore and very thorough explanation will be in steel structures. Engineering mechanics, this is over sufficient. Steel structures, over. Now, this most master question is over. Now, see, now next class onwards, I will write title Calculation of Moment of Inertia in a systematic order, starting from, I don't know, maybe angle once again. There, this much all will not be there. What? Centroidal axis or given some other axis. This mix-up will not be there. This is permanent. This is a permanent reference for you. At that time, I may ask some little extra portion, but we will go for angles because, see, our angle is like this here. Who knows? Angle can be like this. So, some angle section, then I section, T section, channel section, then so many sections where, see, rectangle and triangle, trapeziums, rectangle, triangle, circle removed, rectangle, triangle, semicircle, rectangle, triangle, quadrant, semicircle, quadrant, rectangle, etc. What all we have done for centroid. So same questions I will take there so that I can save time of explaining location of centroid. I can tell centroid, you already did the question earlier, so you write once again that one here. I will tell you at that time. If you don't write, you are losing. Suppose people are lazy, it is already there, no problem. It is a problem only. People who are studying, if I tell they should write once again, they have to write so that when you read later, you should not refer word one. See, everything should be present here. Okay. Thank you. Next class will continue. That is regular basis moment of inertia calculation.